Hello, thank you so much for that introduction. My name is Jan Ergvinje. I'm the Managing Director of Open Cloud, and today I'm excited to tell you about how a reference Open Spatial Computing Platform can enable the Spatial Web. And here goes. Our organization is an advocacy group consisting now of volunteers. We have a mission to drive the development of open and interoperable spatial computing technology, data, and standards to connect the physical and the digital world for the benefit of all. We got 300 members, individual passionate about spatial computing. We got 55 partner organizations. Here are most of their logos. They are startups, larger companies, standard development organizations, as well as R&D institutions. So we started out back in October of 2018 and launched with a privacy manifesto for AR cloud solutions. And in February, we launched 10 working groups. And in the spring of 2019, they worked together, 40 people, creating the very first state-of-the-art cloud report. And that was presented in Santa Clara at the Ericsson Experience Center at our first state-of-the-art cloud symposium and showcase. And lastly, on this slide, you see our second symposium. There we presented the Open Spatial Computing Platform, or our plans to build that. So a little big picture thing here. If you're familiar with Peter Diamandis, he has been talking for many years about exponential growth and the law of accelerating returns. And now he is bringing attention to what happens when accelerating exponential technologies join together. Then you get something interesting. Imagine AR and AI coming together. So here's a list of different exponential technologies, and they can converge in different ways, but one way they are converging is on something called real-world spatial computing. And if we as humans want to put ourselves into the center of this, we can take on the AR perspective. And in 2017, Uri Inbar came up with the term AR cloud. And that is sort of like, you could see it in a simple way, technically, as a 3D spatial real-time map of the world. But that opens up the discussion for a much larger vision. So we have discussed in our organization, in the State of the Art Cloud report, this future, and Charlie thinks convergence. We got the Mirror World article in the Wired magazine, and also one of our partners, Gabriel René, wrote a book about the spatial web. So the whole thing with spatial computing and the real world is it's like a digital upgrade of physical reality itself. And we're seeing some sort of glimpses now on the actual technology coming onto the market. So many of you have probably tried Google Maps Live View, and some lucky guys have tried Hololens. Tens of billions are poured into spatial computing each year. So it's like prime time now. Are we close to going from the World Wide Web to the spatial web? How about these promising startups? Maybe we should start building our technology, our solutions right now on them. But then this happens. Niantic, Lyft, and Facebook acquires the companies. And whoops, all of those SDKs and APIs become unavailable on 30 days notice. How about going for a large, solid company like Google? They have their visual positioning system, and they partnered with lots of larger organizations to let them explore the potential of using their visual positioning technology that also drives these live maps on Google Maps. But even the Swiss railways, they couldn't rely on this, because suddenly out of the blue, Google just dropped their service for their own reasons. Then we have this whole thing around privacy and security and constant reality capture. That is core to the technology. it's what drives a lot of the benefits that we can hope to do this constant reality capture. But that brings in, for instance, from the privacy perspective, you are more or less like a nude person for those who sit on your data. So if you don't control or own your data, then there are so many opportunities to abuse that data about you. And I show you this picture of a lion. If you have a spatial context that knows the real world around you, what is there and where you are and what you are looking at, it might also be aware that you are near a cliff or that you are near a road with a lot of traffic. And an AR device might control your field of view. It might control what you hear. And if you suddenly hear a roaring lion jumping at you, you might instinctively just jump to your death. So that would be a roaring lion attack of a virtual roaring lion. So we can be worried when a company like Facebook, they launch a really broad vision idea about this technology. And they really got all on the technical level. They understand all the potential and how you can build this, but they're not talking at all about privacy. And we're hoping maybe a company like Apple could bring in privacy. They are dedicated to that, but can you afford their devices? And what about standards? Are you going to make solutions only for the AR ecosystem of Apple? Then we got Magic Leap. It's another walled garden, maybe just a magic dream now. So spatial computing as it is now, it's broken. And it doesn't even scale. There's no mass adoption. We don't see a route where we actually have a lot of users and have great devices and have great content available. So are there any solutions? What are the missing ingredients? This actually is the template we should go for. An open, scalable platform invented over 30 years ago. You have a simple set of standards, protocols, services, and clients that just work together seamlessly for any device, any person, anywhere in the world. So is the spatial web just going to use the web? Are we going to use WebXR? And then we're there? Well, we need to think outside of the browser tab. So remember all of these exponential technologies converging on real-world spatial computing. This is exactly the place where we want to have this platform. Imagine making all of these technologies work seamlessly together. But that could be hard, having all of those different technologies working together. So the way to approach this is to keep it simple, stupid. And from our work, this is not simple. So this is a large, complex vision. But when we're looking at the Open Air Cloud framework, there are three core things, three core functions that we should focus on from our perspective. So crystallizing down to these concepts: real-world pose, your position and orientation with 6 degrees of freedom in the real world. It's not only your position, your AR device position, or the position of the virtual object. It could be a car, it could be a robot, it could be anything. But you have a shared frame of reference. Second one is really exciting, to be able to encode a machine-readable description of reality, where all the geometry, semantics, and relationships of the real world near your location is made available in machine-readable form. And when you're there, you have your machine-readable world. Now you can imagine accessing all the kinds of content and services that are available at your location. So looking at this in an overview, just like the web, we have some standards, we have some protocols, we have some services. And you see the GeoPose, we see the reality modeling language. An important thing to think about is that we envision the platform services as commercial utilities for spatial computing, just like ISP or 5G or your electricity or your water. In a few years from now, maybe your teenage kids will pester you to give them a better Spatial Discovery Service subscription or a better GeoPose service subscription. This is the kind of place in the platform that this belongs. So to unravel a little bit about what might be confusing about OpenAI Cloud. So we're not a commercial entity. We're not going to run these services. We're not going to operate them commercially. And we're not either a standard development organization. We contribute to standard development in a standard development organization like the Open Geospatial Consortium. But we do develop and provide open source reference implementations. This platform has 4 target audiences. So first we give this to the potential service providers. Those could be the startups or the larger companies that today have, for instance, a visual positioning service. They could provide a GeoPose according to this platform. Same with all the other services listed. Then you have your end users and customers. They could be regular consumers. They could be regular employees in an enterprise. They could be students. They could be first responders utilizing this spatial computing to save lives. And then you have the content creators and developers. Today, if you are a content creator, you might end up with an AR app that you need to download from an app store. And that is really dysfunctional in a spatial computing settings. So what you rather would like to do is to publish it on an open platform and have it available seamlessly, no matter what sort of device you're coming from. And also, lastly and importantly, those who make AR devices and with client software, that could be your future Apple, your Magic Leap, your Samsung. It could be producers of IoT sensors. It could be producers of self-driving cars, other vehicles, robots. It could all connect to this platform and use the services on the platform. So what have we done so far? The first focus, the most important thing in the beginning is to establish this shared frame of reference. So we made a proposal to the Open Geospatial Consortium to set up a standards working group there. And we started that working group on the 24th of January this year. And it's a sort of basic standard, we're hoping, and we might get that standard ready this year. We got some really great people joining, even people from Google. We got the British Ordnance Survey. And there are organizations that are not participating in the working group that are really interested in this standard. So why are we going geospatial for the post instead of just local? Well, there are a lot of use cases that will fall apart if you are not able to connect to a shared geospatial frame of reference. You cannot work from remotely and place an object onto the real world if you don't have a geospatial frame of reference. Then you would need maybe a live sensor stream or something like that. And also the entire mobile ecosystem and the autonomous vehicle ecosystem, they are already geospatial. So working seamlessly and have great interoperability with all of those use cases requires a geospatial approach. Next, the Spatial Discovery Service. Here's an illustration from our state-of-the-art cloud report. The Spatial Discovery Service cares about the upper part. So there's layers here. The lower layers relate to the physical reality. The upper ones are all the cool stuff you can layer and paint the world with data. And luckily, this kind of service is kind of basic. It just contains a register of references with metadata, and that is reference to the spatial content near you or the applications near you. And also it needs to list the Open Spatial Computing Services. There are some complexities around there. We need to ensure competition. So we need to have synchronization between different providers of the Spatial Discovery Service. And there might also be a hierarchy within like a regional level, maybe national level, and local zones. I'm going to just jump over some of the details. But here on this slide, you see the concept of the edge that is essential to make this technology really fly, especially for real-time application when time is of the essence. So there's this notion that in your local area, there are edge compute data centers that are running these spatial open spatial computing services near where you are, so you have super low latency. Also, we want to, as we mentioned with the privacy, our position is that what happens at the edge stays at the edge. That is the way to approach this. That is, we believe, right, if we want people to trust this technology. So you can check out the Spatial Discovery Service on GitHub. It's actually based on decentralized OpenStreetMap technology in its current inception. So the reality service, for the reality service, we look at the bottom part of this illustration. That's the reality capture layer. And it has a real-time component and it has static components. So the truth now, it's still very early for this part of the platform. We're doing a landscape scan. We're looking at other standards. We're looking for SDOs to work with on this. There's early requirement and design discussions around this. And some of our partners are doing some internal work related to their business that will be discussed internally in OpenAI Cloud. So we're not ready to go public with much on that yet. We have a bunch of other activities. We have a team that is working on prototype use cases. So imagine being the Xerox PARC for spatial computing, reinventing how we interact with the machines and how we interact with the world. We want to make that UX inclusive and accessible. We also plan to hold our first ever OSCP hackathon with a live GeoPose and Spatial Discovery Service available on site for the teams. That has to wait until it becomes possible to meet in person again. There's an R&D institution that is investing some resources into working on the platform. We definitely need to work on fundraising and outreach and recruit more participants and organizations to partner on these activities. So future plans, there are basically three phases: phase 1, phase 2, phase 3, where we're now in phase 1, where we want to design, prototype, and demonstrate the platform concept. We originally wanted to do that, complete that this year. Then Corona happened, and we have to postpone that for the next year to have this first minimal viable set of platform components for a demonstration. Phase 2 is to take this to a solid and scalable mode, where we gather a group of industry partners to work with this to make it really solid and scalable, and make it also technically legal and commercially viable. So that would be some further time into the future, starting hopefully next year. Phase 3, probably have to wait a couple of years for that. But then that's when you're ready. That's when you're ready for the global rollout. And that's where you want to capture the public imagination and invite all the content creators, developers, data providers, and the users to just join in on the platform. So with that, I would like to thank you so much for listening. I'll be available for a few minutes on the Q&A session. And I encourage you to go to openaiacloud.org and sign up as a member or as a partner and join us in our community of really enthusiastic volunteers. Hopefully with some funding, we could also move to the next level and hire some people to work on this ambitious plan. thank you so much, and live long and prosper, everyone. Take care.
Hey.
Thank you, Jan-Erik. Every time I listen to you, I become more convinced of the OARC vision on the open standards to ensure continuity and availability of the tools and data to the developers and end users. Great job. Great job. Thank you.
Thank you for that. I'm glad to hear that from Immersal, which is also a leading technology pioneer. And I heard now you announced covering the entire Helsinki with your AR cloud technology. That's really cool. Would be the perfect thing to set up the demonstration of our platform for like the first view to the world, where we have a spatial positioning service where people can have GeoPose, where we have a reality service and a spatial discovery service, all coming together. And would be great to do that together with you.
Yeah, we'd love to. And as you know, we also have now the GeoPose built into our SDK and to the data structure that we have. And my question anyways would have been, where and when can we experience the first pilot on the OSCP? Is it going to be in Helsinki with us then?
Yeah, let's aim for at least, if we do multiple cities at the same time, then Helsinki should be one of them. And if we
is it going to be
one
Oslo?
place, maybe the second one could be Oslo. Maybe you could have someone at another place. But the key is that you need some people on the ground, because in contrast to the web, which like you fire off your HTTP request and it goes across the planet, and you wait for a little while and then you get your response. And that doesn't really work so well with spatial computing. You want to have low latency, and there might be a lot of data, and there might be a need for local compute. So the whole thing is very distributed. That is an opportunity to change the entire structure of thing, because now local players can be way more important. So you know your local region, you can provide tailored spatial content, spatial services for that area. And that turns things on its head, because now things are super centralized and everything is owned by this little set of giant corporations. So maybe there's an opportunity to reshuffle the deck a little bit.
I agree, and that's what we also want to do. So what do you see are the biggest hurdles in the way to the OSCP, and how to overcome those? Is it the resources or?
Yeah, resources. That could, if you share in this vision, there are many ways to help. So definitely you can come in and contribute on the technical side, on use cases, on content creation. But also you can partner, you can become a sponsor, so that eventually we can have a lot more impact. Because one hurdle now is you see this slow emergence of those existing large corporations that are building spatial computing platforms that will be proprietary, that probably will be walled gardens, so that you are, if you as a content creator, you want to make something, you need to make it here, and you need to remake it for that platform, and you need to remake it for that platform, and maybe some of the stuff that is made isn't available everywhere, and you have the risk of going through many years of this dysfunctional ecosystem that isn't really taking off and is preventing the entire industry from reaching its potential. So yeah, that's a major potential hurdle.
So where is the low-hanging fruit? So where can we start and see basically results here and now, so that we don't need to wait until 2021 or 2023. So what can we achieve this year, this quarter?
This area, we really hope to have this standard that we're working with the Open Geospatial Consortium to have that ready this year. So any company that is into visual positioning, they could look out for that standard and be ready to implement. And it's probably going to be fairly basic, the stuff that is the core use case of the standard. You have your latitude, longitude, and your height, and you have a quaternion that describes your orientation. So more details will come from that, but it's the core of the standard that most people will use will probably be quite simple. So get ready to implement on that. And if you're working on a content distribution platform, imagine you have people uploading 3D models to a content platform. Maybe you can enable a feature where your customers are able to position that content into the real world. So you give your content also a latitude, longitude, altitude, and allow the user to rotate it. Until you have the final standard, you might imagine doing something that's quite basic, but as soon as the standard is ready, then you could tweak it up to be standards compliant. So that means that eventually, as the platform potentially gets real, if you're at a location where there is a GeoPose service, and there is also a Spatial Discovery Service where content is listed from a content platform provider, then your AR app, your AR solution might be able to download that content and display it in the real world in a standard compliant way. So that is one way to get ready. I cannot promise that the spatial web in its full future form is going to be anywhere near ready within a few months. It requires some patience, but the more you get involved in this, the faster we get there. So bring your rocket fuel, and then we can reach escape velocity the much earlier stage, and maybe we can bypass this era potential of walled gardens that doesn't work together.
Thank you, Eric. I hear from the headphones that we need to be closing the session. Very interesting, very important. So let's make sure that the work continues and we start working on short time results also, so that we can prove that the work is valuable. But thank you, Eric. Thank you, Jan-Erik. This concludes the XR enablement track.